Hi guys, welcome all of you. See, we have started already CBSE Class 10 Maths Chapter Real Numbers. This is part 6. In this class, we are doing exercise 1.2, question numbers 1 to 3. Okay, let us start. See the first question, prove that root 5 is irrational. So for that, let us assume that root 5 is rational. Okay. If root 5 is a rational number, then we can write root 5 equal to a upon b, where a and b are coprime and b not equal to 0. You know what is coprime? If two numbers are coprime, they don't have common factors. That means their HCF is 1. Okay. Root 5 equal to a upon b. Then this can be written as root 5 upon 1 equal to a upon b. Okay. Then we can cross multiply this. Then what you will get? You will get root 5b equal to a. Are you following? Okay. Then you can square on both sides. Okay. So squaring on both sides, we can get 5b square equal to a square. Okay. This is the first equation. See this. A square is equal to 5b square. That means a square is a multiple of 5. Is it? So you can say 5 divides a square. Okay. Here see, 5 is a prime number and a is an integer. So we are getting here 5 divides a square, and by theorem 1.2 we know if 5 divides a square, we can get 5 divides a. Okay. See this. So 5 divides a square implies 5 divides a. Okay. 5 divides a means 5 is a factor of a. Is it? So you can write a equal to 5c, where c is an integer. Okay. Then this was the first equation, 5b square equal to a square. Already we got this equation, is it? In this equation, instead of this a, we are substituting 5c. Okay. Then what we will get? 5b square equal to a becomes 5c. So 5c whole square. Okay. Then you can write 5b square equal to 25c square. Okay. Are you following? Okay. Then you can cancel 5 from both sides. Then we will get b square equal to 5c square. Okay. That means b square is a multiple of 5. That means 5 divides b square. Okay. So if 5 divides b square, then by theorem 1.2 you can say 5 divides b. Okay. So here we are getting 5 divides b, and already here we got 5 divides a. So we are getting here 5 divides a and 5 divides b. 5 divides a and 5 divides b. That's it. That means 5 is a factor of a and b. That is 5 is a common factor of a and b. That's it. This is a contradiction to the fact that a and b are coprime. Why this contradiction arised? Because our wrong assumption. What was our wrong assumption? Root 5 is rational. Is it? That means root 5 is irrational. Hence the result. Okay. All of you understood? Then come to the next question. Question number 2. Prove that 3 plus 2 root 5 is irrational. So here to prove that 3 plus 2 root 5 is irrational, we are following the same procedure. What was the procedure? We are assuming that 3 plus 2 root 5 is rational. Okay. If this is a rational number, then we can express this in the form A upon B, where A and B are co-prime and B not equal to 0. Okay. So we are writing like this. 3 plus 2 root 5 equal to A upon B. Then here we can take this 3 to this side. Here it is positive. So when it comes to this side, it is minus. Okay. So we are getting 2 root 5 equal to A upon B minus 3. Okay. Then you can write it as 3 upon 1. A upon B minus 3 upon 1. Cross multiplying this, you can write A minus 3B upon B. Okay. So we are getting a 2 root 5 equal to A minus 3B upon B. Now we are taking this 2 to this side. So what you will get? Root 5 equal to A minus 3B upon 2B. And see this, A and B are integers here. So A minus 3B upon 2B is rational. Okay, it's a rational number. So what we got here? This rational number is equal to root 5. This is a contradiction because root 5 is irrational. An irrational number can never be equal to a rational number. So we are getting a contradiction here. The contradiction is arisen because of our wrong assumption. Okay, what was our assumption? 3 plus 2 root 5 is rational. This assumption is wrong. Okay, that means 3 plus 2 root 5 is irrational. So we have proved the result. Okay. Then question number 3. Prove that the following are irrationals. First one is 1 upon root 2. So we have to prove that this 1 upon root 2 is irrational. We are following the same method. That means let us assume 1 upon root 2 is rational. Okay. So 1 upon root 2 is A upon B. This A and B are integers. They are co-prime and B not equal to 0. And one more thing, this A cannot be equal to 0 because if it is 0, A upon B will be equal to 0. Is it? But here it is equal to 1 upon root 2. Okay. Then cross multiplying this, you can write B equal to root 2A. Okay. Then take this A to this side. Then we are getting B upon A equal to root 2. And we know B and A are non-zero integers. Then B upon A is a rational number. Is it? But that is equal to root 2 means it is a contradiction because already we know that root 2 is irrational. This contradiction is arisen because of our wrong assumption. What was our wrong assumption? That 1 upon root 2 is rational. That's it. That means 1 upon root 2 is irrational. So we have proved that 1 upon root 2 is irrational. Okay. Have you got it? Then come to the next question. Prove that following are irrational. Second one is 7 root 5. So we have to prove that 7 root 5 is irrational. Can you do it? Anyway, let us do together. Okay. We are assuming that 7 root 5 is rational. Then you can write that 7 root 5 equal to A upon B, where A and B are co-prime and B not equal to 0. Okay. Then you can take this 7 to this side. Then we are getting root 5 equal to A upon 7B. Okay. Then you see this A and B are integers. So you can say A upon 7B is rational. Is it? This is rational. But already we know this root 5 is irrational. A rational number cannot be equal to an irrational number. So, we got a contradiction here. Is it? Why we got this contradiction? The contradiction is arisen because of our wrong assumption. What was our assumption? Our assumption was 7 root 5 is rational. Is it? So, this assumption is wrong. That means 7 root 5 is irrational. Okay. So, we got the result. Okay. Then come to the third one. Prove that following are irrational. 6 plus root 2. So, here we have to prove 6 plus root 2 is irrational. So, we assume that 6 plus root 2 is rational. We can express 6 plus root 2 equal to a upon b, where a and b are co-prime and b not equal to 0. Okay. Then, what is it? You can take this 6 to this side. Okay. Here it is addition. When it comes to this side, it becomes negative. Okay. Root 2 equal to a upon b minus 6. This can be written as 6 upon 1. Then you can cross multiply this. Then you can write a minus 6b upon b. What about this? Here a and b are integers. So we can say a minus 6b upon b is rational. Is it? But what about root 2? It is irrational. Is it? So irrational number is equal to rational. That means a contradiction arises here. The contradiction is arisen because of our wrong assumption. What was the assumption? 6 plus root 2 is rational. That was our wrong assumption. So this is wrong. So we have proved that 6 plus root 2 is irrational. Okay. We have completed that exercise and that chapter is over. Let us just go through the summary. Okay. See this. In this chapter, we have studied the fundamental theorem of arithmetic. What is it? Every composite number can be expressed or factorized as a product of primes. And this factorization is unique. That's very important. Apart from the order in which the prime factors occur. Okay. The next one, if P is prime and P divides A square, where A is a positive integer, then P divides A. This is Theorem 1.2. Okay. The next one is, we have proved root 2 and root 3 are irrationals. Okay. I think all of you understood all these facts. Yes, sir. If you haven't understood this, you just go back to the earlier lessons and watch it again and you will understand all this. Okay. So, we have completed this lesson. I think all of you understood this. Thank you for watching. Let us see in the next class. Okay. Thank you.